Dynamic programming splits a large problem at every possible point. So it will split the large problem. So if the problem is PB, it will split PB to smaller problems, say PS1, PS2, and so on. And when the problem becomes sufficiently smaller, dynamic programming solves it. Dynamic programming is a bottom-up approach. It finds the solution of the smallest problem and constructs the solution of the larger problem from the already solved smaller problems. To avoid recomputation of the smaller problem, dynamic programming saves the result of the subproblem into a table. So when the next time comes, the same problem encounters, the answer is retrieved from the table by a lookup procedure. So a bigger problem is divided into smaller problems, and these smaller problems are added to get the result of the bigger problem. So what was happening in case of greedy method? In greedy method, we were choosing the most optimal solution. Which was lesser cost. So it gave you a less cost. You don't have to spend much on that, and the product was more. So the weight produced was always more. Profit was more. Profit was larger. So you always chose that part which had more profit. Whereas in case of dynamic programming, you will evaluate all the paths. Dynamic programming evaluates all paths and then decides which is the most optimal path. So first what it will do, it will evaluate all the paths, then decide which one is optimal. In case of greedy, first you decide the optimal and then you evaluate. So first decide optimal, then evaluate. In dynamic, first evaluate, then decide which one is optimal. So algorithm for dynamic programming: if the solution is solved for P, then enter the lookup of P. Else, solve first P and store the value in answer. So answer will be P comma answer. So store what? You will store P comma answer. Solve the P and assign it to answer. Now function for solve P. If P is sufficiently small, then the solution will be P itself. But if P is large, then what we will do? We will divide P into smaller sub-problems, say P1, P2 till Pn. Then P1 will be stored as answer 1, P2 will be assigned to answer 2, and finally we will return a combination of answer 1 plus answer 2 plus answer 3 and end. So in dynamic programming, if the solution is small, then return the solution, else divide the problem into smaller sub-problems and then add the result, that is the answer of that smaller sub-problems, and then return the value. What is principle of optimality? The principle of optimality is the heart of dynamic programming. It states that to find an optimal solution of the original problem, a solution of each sub-problem should also be optimal. That means when you want to find the solution of a larger problem, then the solution of the smaller problems PS1 and PS2, these PS1 and PS2 should also be optimal if you want the larger problem to be optimal. It is not possible to derive optimal solutions using dynamic programming if the problem does not possess the principle of optimality. Shortest path problem satisfies the principle of optimality if A, x1, x2 till B. So if it is said that A and B, A to B is the shortest path. So we say that A to B is the shortest path. Then A to x1, x1 to x2, x2 till x, and whatever comes, all these subpaths must be smaller. Means they should also be optimal. If you want this to be short, then even this should be short. These should also be small paths. Then only we can say that it is following the principle of optimality. Then only we can say that the path A to B is optimal.